we should start seeing something come through. And because it's always like this, I have to check and make sure. And that's coming through. And say something.
Testing 1 2 1 2 check check.
And say something.
Testing 1 2 1 2 check check.
Perfect. Okay, so we have no Jess today. Jess was at C++ North in Canada, doing a keynote, which was apparently good about actually delivering software.
That's C++ actual North, very very true North.
Exactly, yeah. I
Yeah.
mean, not .NET North, which is kind of halfway up the UK. This is actual North. But apparently, so I was looking at this a while ago. I can't remember. I think it might be on one of Layla's streams where we're looking at what our is it latitude
Yeah.
crosses over to, which is like northern Canada. So
Really?
it might actually be that we are more north than
Oh
C++
God.
North.
That is a very very Mancunian attitude to proving where the real North is.
Very much so. Very much so. So yeah, Jess won't be joining us, but I thought I'd take the opportunity. So I've been building a little application for doing something called sampling. And I've written it all in .NET. Me and David have got a history of the last couple of years of building outside in testing. I've done a talk on it. David's done a slightly different talk around writing tests that don't suck, which we should always strive to. That should be the bar. Let's just make the test not suck. That should be
So I'm here to judge Martin's tests.
basically, yeah. So go on, you tell everybody. I would imagine you're more famous than I am, so everybody knows you, not me. But let's assume that there's maybe one person who doesn't know who you are.
I'm disgusted at the idea that people haven't heard of me. No, I jest. No, so my name's David Whitney. I spent years being an independent software consultant around the UK, mostly bothering people who build software and really caring for about how they do it. People may have seen me talk around at the moment intentionality in software design, which sounds like a highbrow philosophy and is really just making software that isn't hateful.
Yeah, yeah. I mean, the being intentional means that if you write bad code, you intentionally wrote bad code.
Yeah, exactly that. Like you die by your own sword if you're choosing it. I guess really, the pressy of that entire way of thinking is that like the only way we ever make good software is if we actually care and pay attention to the reasons why we make every choice we make, and it permeates everything we write. So if we don't really think and agonize over the detail, then you just get dross over time. Over time, the code rots away.
Mm.
And that's kind of the lens, and I suppose that's the grandstandy version of a much more nuanced and gentle talk.
So go see the talk.
Yeah.
Or do we not need to now that we've just had that bit?
Yeah. TLDR, care about everything. Otherwise, everyone will be sad, and we don't want to make people sad.
But if we care about everything, if we care for everything, then don't we care about nothing?
It's just existential nihilism. If everything is important, then nothing is important.
Exactly. I mean,
Yeah.
that's something we talk about a lot at Honeycomb, especially when it
Quite.
comes to monitoring and alerts and that kind of stuff. It's like, I have 10,000 alerts. They're all important. Well, if all of your alerts are important, then none of them are important. So just delete them all.
You know what? Philosophically, I think I'm an optimist. I take the opposite perspective. I'm fundamentally a nihilist that believes nothing is important and nothing matters. But when nothing matters, all we have is important. Everything that we are is important, and what we're doing is important if nothing really matters, because it's all we got.
So welcome to something philosophy.
Yeah.
Right, okay. So
existential dread and code.
Now that's a talk I would go and see. I mean, that sounds like a pubconf talk, really. And this, ladies and gentlemen, is what you call nerd sniping. Okay, so the way I thought we'd run this, I have some code, and we can go and look at some code. What I also have is a bit of a diagram to describe what it is that we're doing. So what we're talking about is something called sampling. And I've wrote a few posts on this. sampling is really about how do we take a small amount of data but make it representative enough that we can extrapolate close enough to what the real data would have looked like. And the problem that we're trying to solve by doing this is a cost and performance problem. Because if we've got 1 billion data points, it's going to cost us a lot to store that data, and a lot of it is probably the same. And if we have to trench through 1 billion data points in order to write a query, then that can take longer and cost us more as well. So cost and performance are why we would sample. But when we sample, we're essentially losing quality. So if you think about things like the JPEGs use sampling in order to get smaller sizes so you can then extrapolate up, but you lose quality. Generally, you get something that looks pretty right until you start to really delve in. But what we're doing is we're taking away some of the common data and then saying, oh, you can extrapolate it up like this. And that's,
I guess, sampling is the antithesis of detail, right? It's literally the opposite. It's data to spot trends rather than data to get specific answers.
Yeah. And the problem that we've got in telemetry is when we do sampling, if we don't do it with intelligence, if we don't do it with intentionality around what it is that we're trying to do, if we just go, oh, I'll randomly choose a few of these spans and yeah, that'll be fine. I'll choose 10% randomly of these spans and just say, yeah, that's representative of data. Data is not uniform. Your traffic is not uniform. If you take 10% of data from 9 a.m. to 10 a.m. in the morning and extrapolate for 24 hours, that's not going to be representative. So there are things that we do in order to be sure we get a representative sample. And there's a couple of different ways in OpenTelemetry that you do that, which one of them is called head sampling, which we do when we create a trace. We do it right at the start. You have very, very little information to go on, like, oh, is this a bot because it's got a weird user agent, or is it for our health check endpoint? And we can do that pretty effectively and just say, yeah, we only want 1 out of 10 of these. But when it comes to things like, I only want to keep the slow traces, the ones that took us a long time, those are the only ones I want to keep. Or I only want to keep the errors. Well, when the request came into my system, I didn't know it was going to be an error until afterwards. If I knew it was going to be an error, I probably wouldn't serve the request. But, you know, I want to, at the end of that, work out, well, I only want these ones. But I also want to say, if I've got a request for my product endpoint and I'm getting a 200 OK and it takes 10 milliseconds, it's not going to be interesting data. Why am I keeping all of it? You know what? Just send one and say there was 15,000 of them. But I also want to be able to do cardinality of data. So maybe I want to be able to say how many product IDs were done. So if I just take 10% of them and they're all for product ID 1, I'm not going to be able to extrapolate and say how many product IDs were hit. Was it certain product IDs were being hit more than others?
So before we push on, I'm just looking at the chat. Apparently you're a lot quieter than me, which is this the first time for everything.
Yeah. I mean, wow. Okay. No, this is a known problem in my OBS setup, apparently.
Your life.
So, yeah. If I do that, bring up the mixer. And, apparently I'm going to need to go up to 4,000% now. So we'll try that.
Perfect.
And I will move this closer to my face as well. So hopefully that will be a little bit better for people.
So let me try and play back to you what I think I just heard in the context you described. You try to build a thing that when we start emitting data from spans, and that's good apparently, that we can, based on the context of the application and the developer building it, put together some rules or filters or some way to basically highlight specific data as interesting and other data as like, yeah, well, we know we don't really care about those 200s because, yeah, send one every 10,000, whatever. Like, it's all fine.
So, slight bit of nuance. What we don't do is we don't slim down the spans. So, in OpenTelemetry, span is our unit of currency.
Yep.
And that's a bag of data about a specific action that happened.
Yep.
We stitch maybe 10, 15, 10,000 of these together using something called a trace ID. And that then
Yep.
becomes a trace.
And that's
Now,
basically the correlation of the entire journey through an application stack and systems and whatever, right? Fine.
Yep. And what we do then is, in the sampling world, is we take that whole bag of a journey and we analyze it together against other things that are the same. So if we've got a journey that is add something to a basket, which will go and touch a product service, and it'll go and touch another one. If 10,000 people do exactly the same thing and it always returns pretty much the same results, then we can just say, yeah, there was one and there was 10,000 of them.
Yep.
What we've got to do when we do this, and it's not when you write the code, it's when you are building your telemetry pipelines afterwards, because these can be changed in real time without changing code. We've got to work out what makes them common, what things make them different, and what things make them common. So is duration something that makes it different? Is a ID of a product something that makes it different? Is the URL something that makes it different? Because that's how we can then bucket things together and say, these are all the same, but only send one of them and say how many there really was.
Okay, perfect.
Okay. So when we're building a tail sample processor, now I'm going to have to switch my share and share a screen to other people, because I've spent a lot of time on this because we have some incredibly talented people at Honeycomb. And the problem, which I've never really hit myself, is when you are incredibly intelligent, you explain things at a level where not everybody understands them.
It's a good job I'm a colossal idiot.
Heard it here first, folks. So I'm assuming you can see that, David.
I got the diagram.
Yeah. So, and it looks like everybody else can as well. So this is what I would consider the anatomy of a tail sampling processor. Now, when we do tail sampling, we do it at the end. So we don't do it at the start when the request comes in. We do it right at the end, which is right down on this side over here. So we've got a load of spans that are coming in. The colors here denote different traces. So we've got some orange trace, we've got some pinky reddy trace, and a purpley trace. Now those all go into something called that we'll call a span receiver. So it's just going to receive these in. We'll be doing this through OpenTelemetry line protocol, which is a standard format for these to come in. We've then got to make some decisions. We've got to store that data for later processing. We've got to, if it's the root span, so the first one, we then say, oh, in 5 seconds afterwards, go and process this thing to give us some time for all of the spans to come in. Because the other thing to note is that if you've got a microservice solution where you've got, say, 7 or 8 different services that make up one trace, all of those spans are going to come in at different times, because they're all on different cadences. So your checkout service might be send spans every 5 seconds, or if I hit 20,000 spans in my buffer, send them immediately.
Yep.
And that might be slower than something else that's basically every 10 seconds. So they're not going to come in at the same time. So we have to put in some kind of delay that says, do it after a particular time. So we have to say, take all these things, just dump them down into the data store. And if it's the root span, so we've just got our main span, the one that the user hit, then we'll send a time trigger and say in 5 seconds time now, give it some time for all these other ones too. It might be 5 minutes, it might be a minute, it could be, it's specific to people's systems. And then when that triggers, we're then going to do some processing. We're going to go and get all of the trace data, all of those spans. We're going to make some kind of correlation or a trace key that will say, what's the uniqueness of this particular trace? Or maybe it'll be add up all the 200 responses, add up all the 500 error responses, and we'll make something unique, which allows us to say this trace is like another trace. And then we make a decision as to whether we're going to sample it, which means send it on. And we do that and send us what we call a sample rate to say, here's one, and it's been sampled at 1 in 1,000. which means there were 1,000 that looked exactly like this, which allows our back-end tooling to make some decisions. If you've used application insights and log analytics, there's a difference between count and there's a count and log count or something like that. One of them is the actual number, and one of them is the
number of lines you have.
Yeah. So we send that through, and it goes out to Honeycomb via an exporter. There's a load of nuance that goes into this, though. So one of them is that our sampling decision, if our spans come in after we've already made a decision about this trace, we're not going to make a decision again. So as it comes into here, we have to say, have you already made a decision on this trace ID? Yes. All right. Bypass that and go straight to the exporter. And that will say either delete it or send it on straight away. And then we've also got these trace processors which have complex algorithms that allow us to be able to say how do things, where do we get that commonality from, but also being able to say how many should I send, how many shouldn't I send. So that gets really complicated. The span receiver can get really complicated in that I'm going to send it to some stores and all of that kind of stuff. One of the biggest problems, though, is the time trigger. To be able to say, do something in 5 seconds. Being able to do that at scale. And we're talking about customers that are sending 120 million spans per second to these kind of systems. This is not small scale because telemetry data is huge in terms of volume. So they're sending like 120 million of these. So how do we then say, of these 120 million, if they're going to be backed up for 30 seconds, and then we're going to have time triggers for 30 seconds after that, you've got a minute of 120 million spans. You know, we're hitting a data store of 1 billion spans that are constantly being cycled. And we're hitting a timer trigger that's going to have to maintain timers to trigger something at the scale of about 1 billion timers. Which I don't know if you've tried running the timer object in .NET and storing 1 billion of them in memory, but I'm not entirely sure. I mean,
doesn't sound like something I would recommend doing.
I'm pretty sure SQL Server would use less memory if we did that, because you know the joke: how much memory does SQL Server require? More.
Yeah.
So yeah, there's all of these nuances that make this hard. And my own hubris said, well, tail sampling's easier. You just take some spans, store them, and then at a later point go and process them, and it's just some algorithms.
That is an accurate description of the problem.
Yes.
But just as doing all the work.
Yes, it's playing a big role in that statement. Yes. So I was like, great. Well, I know .NET. And, as if you believe the Microsoft announcements, .NET is faster than Go and Node and C++ and assembler and, mining your own silicon and building your own circuit boards straight for this, if you believe the marketing hype. But I know .NET. So I thought, let's go and write something which will help me understand why it's so hard. Because the only way for somebody like myself to have their hubris dashed is to, be able to say, yeah, I actually couldn't do it.
Are we going to get to use spans to process spans so we can send spans to your span store?
We might well be able to do that because, yeah, I've been talking about this. I was actually talking about this with Michael Stabe about the performance stuff he's done with GraphQL and how they're going really deep down to move pointers using unsafe because the for loops weren't fast enough for them. So I'm really excited to get to that level of optimization. But as it stands at the moment, we are nowhere close.
Mm-hmm.
Okay, so now the other thing I wanted to do when I did this was I wanted to stay true to the stuff that me and you have been doing over the last couple of years, which is doing something called outside-in testing. So the idea that I don't want to write unit tests for each of these components because I don't care if they work on their own. I care more that the whole system works together, that I can send in spans and the characteristics of how they come out on the other end is the correct way of doing it. So I started out writing this and I've hit a ton of roadblocks. There's been previous streams where people have watched me trying to make gRPC work and then couldn't make that work, and then playing around with the internal versus external because I'm pulling in protobuf files from that have made them public and then couldn't. Yeah, it was a whole thing.
Of course.
So now I'm at a point where I've got some tests. They work. I haven't got a ton of them, but I have some tests that work. I have a framework for those tests as well. And I'm at a point now where it makes sense to me. But I'm way too close to this. And what I really want is for this to be accessible to lots of people. So I thought I'd choose the village idiot to come and have a look at this and tell me what doesn't make sense. Your words.
A dunce cap on. Yeah.
Oh, no, sorry. Colossal idiot, I think was the.
Colossal idiot, yeah.
So I thought I'd bring you along and you can basically critique my code. I've set aside an hour after this to sit in a corner and cry at how bad it was. So we'll be good. We'll be good. It's fine.
Yeah.
So, right, let's share some code. Where is my VS Code window, which is that one there. And then let's share the VS Code window for everyone else as well. So, David, you should be able to see it, and everybody else online should be able to see it too.
There we go. Yep.
Okay, so let's close a load of these windows. Close all. So, you understand what we're trying to achieve, which is send some data in, something comes out the other end. I don't have any algorithms right now. I don't have a trace key store for sampling decisions. All I have right now is a single controller. Well, I have got a service for that. You'll be pleased to know as well, and I know David very well in terms of he hates the idea of a controllers directory and a filters directory and a middleware directory and stuff like that. He likes things to be by concern. So that is what I actually did. So
you passed the first test. I can see the feature.
Yep, trace ingest.
Trace ingest. That's what we're doing.
Yep. It should actually be span ingest, just to be very clear. But we'll just go over that.
We'll go with it.
But the idea was there's two different types of ingest. You can do it through gRPC or you can do it through HTTP protobuf. I've only done the protobuf one for now, which is pretty simple. Take some data in, store some data, and send some data out. And there's a few bits behind there. And I have some tests. I have loads of stuff that makes sense to me and is probably not the right way of expressing this to other people. I've done some really cool stuff, like being able to set when a test fails, being able to set some span data that says test outcome by catching first chance exceptions, because in XUnit there's no test context in V2, so I couldn't do it. And yeah, there's pretty cool stuff in there, but the tests are what is the interesting part. And I've just done what I hate, which is, spend ages without getting to the real goal of some code to see. So these are the tests.
Right, so we're okay, cool. So let's do a bit of a cold read here to see what I see. So, okay, first, an obvious case, I get a span. There's probably some kind of default. So you've got like a test data builder pattern coming in here. So a test generator, a valid test trace export. That's good. I presume we don't really care about any of the data in that yet. So
all we care is that it's valid.
Yeah, there is one. It's valid. I'm happy with that. And we've got an API post export request. So that was the controller function that we saw in the other file.
So, and that's interesting. Go on. When we get to the end,
Right, and then we're passing that in. We're getting a result. We're making sure that the result has been accepted. That all seems wonderfully mundane to me and about as simple as we get.
Yeah. So the post export request is actually using not the controller. It's going through
right,
the
of course, because
factory.
Yeah, of course. So you basically got an in-memory representation of the application. So you got an extension method here that's doing the nasty protobuf. Hand me together a protobuf message that I can pop through the top of this application. Yeah, cool.
So abstracted that away. I mean, that could maybe be called something a little bit better.
I think it's, given that there's only 2 HTTP endpoints in this entire application, while we could rename it, I think it's tolerably fine. It's, as soon as you look at it one time, you're never going to be confused again, I guess, is the thing there.
Cool. What about this? So calling this get valid, create valid trace export, is that?
I think export feels a little bit redundant. Okay, so the question there is like, what am I exporting from? Like it makes it sound like there's a block of traces here when I'm presuming, given this is the one example, that this is really, you're creating a valid span. It's a single span.
So not
But then
exactly.
but actually what you're making, so it's interesting as I think through this. Actually, I think the post export request extension method there is actually because it's doing the protocol munging, and this is a DTO, right, coming out here. I'm guessing this is either a blob of JSON or an object that represents the data structure.
So what it is something called an export trace service request, which is a name given to it by protobuf, which is where the
Cool.
trace export came from,
Gotcha.
because it's
Yeah.
an export trace service request. Now, one of the things I was looking at doing was create valid trace export request. I didn't do
Yeah.
that because that makes it sound like a HTTP
Yeah.
request, which is not
It
what it
really
is.
does. I almost feel like maybe one of the things I'd do here, and I don't know whether it's right or wrong yet. I'd have to push it around. I would almost externalize the data part, because what you're doing is you're saying create me one of those trace export service request factory function factories for this particular pocket of data, where in this particular example we're using the default. Right, so we have some example test data. This is using the default, and then it's marshalling it to this wrapped object.
Oh, it does a
Yeah,
ton of
like
stuff.
yeah, all that stuff that I never want to see again in my life. Right.
Yep.
So I think what we maybe have done here. What does a span like? It's really just the key value, isn't it? The key value is the data
Not
that we.
exactly. So the trace
Oh,
export
that's
request.
metadata, right? Yeah, I see. That's metadata. You got some attributes down at the bottom and the span
Yeah.
IDs.
So you've basically got this resource, what they call resource spans. So the
Yeah,
hierarchy works that you've got resource spans, and then inside of a resource span, you've then got scope spans, and then
that's
inside of a
fucking ugly,
scope
isn't it?
span, you've then got spans, and that's all about attributes. So to be able to say, if I want to keep attributes right at the top layer, it reduces my data volume.
So I would maybe there's another way you could do this exact same thing, right? Where we have a class representing just the shit we care about in the spans, right? So it's basically that application identifier stuff at the top with your application IDs, and there's basically a span which is just a dictionary of key, value,
So hold that thought then.
value.
Hold that thought then. So let's just get on to this second one before we go on to that first one. I think
Yeah, I
you've said that will make sense
I
to
will
you.
put my chainsaw down. I'll put my chainsaw down.
Yeah. Just. I mean, you don't
Yeah.
have to turn it off. You know, it can still be like humming along. You might need it in a minute. And I want to, just for everybody else who's looking, this might sound like we're being picky, pedantic about this stuff, but it's the important stuff, because if we're going to use this to build thousands of tests that allow people to understand the application and how the application works, getting the terminology right is really important, and getting the structure of these tests is really important. So I may only have 10 tests, and it'll probably take us, I don't know, another 45 minutes to get through them to make sure we understand them. But that's the important stuff, and people should be spending time on this.
Now let's see what we got. A single root span. Okay, so I think, and again, given my very, very surface level knowledge of OpenTelemetry, when I hear the word root span, I presume that top span that all other child requests are nested under. Is that correct? Okay, fine.
It's categorized in OpenTelemetry as a span that doesn't have a parent.
Fair. Okay, so we've got a service name, some junk that I don't care about. Already, I'm a bit sad that I see it there, because I know I don't care about it because it's a random GUID. Export request service export service request builder with service. Okay, fine. I see. With service name with trace. Now this is a lot nicer because at least I'm getting a sense of the thing here. Like with root span with trace with root span for service. That's a bit a brain teaser with root span. Because I feel like if I'm trying to represent a root span, it's the thing that I would define first and then add data to it. Whereas here, it looks like I'm with service with trace. The fact that the root span is nested inside this little DSL is a bit peculiar, but I can let that go for the moment. So we have a request, and then we're in the same thing that then marshals that request into a call to our controller. We'll grab the first one, we'll grab the data. Cool, we get something, and then yeah, it should have a single item. Yeah, perfect. So your test name's wrong, because all we're really checking here, what you're actually testing for, is that a single span is sent to Honeycomb.
Okay. So change that to single.
Single, yeah. Because that's actually the thing that we are asserting at the bottom.
I mean, you could even go and do that.
Yeah.
Would make the same, because that
makes
links
sense.
that to this.
Yeah, I can go with that.
Yeah.
Yeah, I think the builder there, I love what you're trying to do, but I'm not sure it's working for me perfectly.
Yep.
But we'll do a second pass over it. I feel like what I want to see is almost like an object initializer, or just like, here's a span. We will default the service name in the constructor of some type that we make, because we don't really care about it unless we really want to set a specific value. So it all just takes care of itself. And the fact that you have to new up a new GUID, cast it to a string, add it to a builder, is like busy work in this test.
Yeah, I mean, you could go that one, say.
Some bullshit I do not care about at all. But again, if you're doing that, well, why are you doing it at all?
Because it needs to be in those two. That was the reason why it was there.
Does it need to be in those two?
Yeah. So
can your newed up builder not generate a default one unless one is provided to it?
And this might be historic when I built the builder, because it took me quite a while to get the builder working. So it does kind of work. So the thing that you need to know about an export service request that maybe isn't clear, that's probably OTel knowledge, is an export service request can have spans that don't have parents, so no root spans. Because if it's for the descendant service, none of the spans are going to have root spans. So think BFF. Think about the BFF. The BFF is the only thing that's going to have root spans. Your product service, your pricing service that sit behind
it's
the
just
BFF
the stuff in the middle.
Are always going to have no root spans. So we need to be able to check that we are able to send an export request that doesn't have a root span. It can also include multiple traces. So it's not one export service request per trace.
Gotcha.
And it can also have multiple services.
Yeah, this is basically an envelope for spans.
Yeah, it can have tons and tons of different data in it. Now, if you were serving this, so if you had those applications we talked about, BFF, pricing service, product service, sending straight into this proxy, yes, one export request would be for one service. If, however, you went through something like a gateway like the OpenTelemetry collector does, all of those services would be forwarded into the collector. The collector would then be forwarded onto us, and that would munge everything together.
Gotcha.
So we've got to be able to cater for all of those scenarios, which is why this was built that way, to cater for those.
I don't have any
default it, though. I don't know.
I don't have any context for this joke, but the last time you said hotel, in my head, Hotel California just started playing by the Eagles. And somewhere at some point, you're going to have to get away with using the joke Hotel California. You can have that one for free. You can have that one for free whenever it's useful.
So if you come and see me at one of my talks, I've got Copenhagen at the end of this month. You're there too, aren't you? So we've got Copenhagen
on my birthday.
And then we've also got Porto in October. So if you come to either one of those, I will try and squeeze Hotel California into one of those talks.
Or we'll do it karaoke afterwards.
Living it up in the Hotel California. I love it. So we do actually have a sticker that says, "Oh, tell me why I need to instrument my code."
I think I basically now hate myself, but it's fine.
Yeah.
Nothing new.
Yeah. So I do like having in jokes in my talks. I don't know about you. So I have this thing, Khalid does it's not .net, it's DOTNET. So drop the dot. So in speaking, when you're trying to get the work out when the clicker's working, you have two slides that are almost the same, just like with an extra full stop or something that you know what you're looking for, but nobody else does. So I changed my slides. So one slide says .NET with a dot, and one says .NET DOTNET. And you do that at the start of the talk, and you can see the people in the audience who followed the whole drop the dot drama. You should Google hashtag drop the dot, everyone. And yeah, you can see the people in the audience who actually know what that is. So anyway,
all right, so
back to the code.
We've dissected that, and I think we can do a better pass on that. Let's continue down. That test makes sense to me. I think these are pretty good. So, okay, again, I hate this one by default as well, because what's happening here? Syntax. You've murdered me with syntax.
Okay.
Single child span does not send. Okay, that's an interesting. Is this because? So okay, let's validate my assumptions. You said to me about 5 minutes ago that if I'm some service midway through my stack, so a BFF for a web app starts the root span. I've got a catalog service, a user service, and a basket service, and a checkout service, right? Fairly mundane e-commerce kind of setup. Surely, if I have a span being sent that comes from the basket service, because the web app didn't, that would be a single child span, right?
Yep.
And we're not sending those. I don't understand why we're not sending that.
Because I can't make a decision on it yet.
Okay, because we're the bit in the middle. They have sent that.
Yep.
We can't send that because we're the processor.
Yep.
Got you.
So we've got to make sure that when that comes through, it just gets held in memory until we receive the root span.
Okay, so stuff that isn't important here at all in that test is all the stuff about the trace in the middle. Where's the bit that makes it a child span?
The fact that it's not a root span.
And you see, this is why I don't like this builder again, because that's invisible subtext in this test.
Okay.
Like it's not there, because I look at this and I think, I don't care about anything between line 54 and 57. That feels like something that should go into a builder class of with default span or valid span or something. It's very
ultimately in this test you can actually remove that. So those don't matter. You
so I don't care about those.
Evident testing perspective, that didn't matter.
I'm also not interested in the parent span ID other than there isn't one. Right?
Yeah.
And maybe one of the things that I would do here is I would actually make this test longer, not shorter, by introducing a variable above that export request, where I would give that random activity span ID a span that doesn't exist yet, or span I haven't seen yet.
I'm with you.
Because then I'm correctly telegraphing like that. What I'm doing by putting that on its own line is showing people that this is important. This is the piece of information you should be looking at when you look at this piece of code, because it's the bit that changes the behavior. Because you look at something, when it has a name like that, you read it and like, oh, okay, I get it. That's kind of important. Whereas everything else in there, like the fact that it's called Service 1, couldn't give two shits.
Well, then we get back to this one here of saying that doesn't matter.
Yeah.
We do need it to have those two in there, and I can't remember when we have a look at the builder. It might be that those can be removed.
Why on earth is? Oh, it's underlined because it's not been used yet. I would also put an empty line between those two pieces of setup and that export request, because I think there's a very, very nice flow of like, here is the data that is important for this to work. Here is a thing that we need to make look tidier that I don't really want to read any of. Just presume that this is the correct shape.
Yep.
Do the result, verify it. Okay, so it does not send. Okay, yeah, cool. That makes sense. Like, your assertions are really tight. Like them. Really like them. And I guess I'm going to...
This is where things start to get a little bit more interesting.
Right. Okay. So, again, trace ID and root span ID, they're called out as two distinct things. Now, my code blindness looks at this and says, cool, those are the same thing. So let me read this really carefully. So that I've just failed the sight reading thing.
Yep.
So I like the fact you've called out on line 74, child span only request, right? Because now I'm like, something special about that. At a glance, I don't know why it is. So let me read. So nothing to do with the trace IDs. Don't give a shit about the attributes or values of service. So root span ID. So root span ID seems important because it's been used there, but it's the same in both of them. With service, with trace, with span, with attribute. I don't get it. What am I missing? Why can I? What makes that a child span only request and the one underneath it not? Oh God, no! It's line 80 and line 93. It's literally it's the name. It's parent span ID and span ID. That's properties.
Yeah.
Now,
So
that line 80 and line 92 are the two pieces of information that I really care about there, right?
So that
Everything
would
else
actually
is
be
noise.
probably better that way around. So create the root span only request first.
Yeah.
Then create the child span only request.
Yeah.
Then do them in the inverse order.
Yeah. I know I keep on wailing on the DSL here. I think the DSL is burying the intent because these are perfect. Like the tests themselves are very good and very tight. The DSL makes it confusing to see, and it's better. The more we take out, the better it becomes.
Yeah.
Because the more we remove, the more chance it is. And you just watched in real time as it took me 30 seconds to notice that one was span ID and one was parent span ID.
Yep. So that's still the problem because it's not highlighted.
Yeah, it's just kind of in
really
the middle of that dense block of code. Yeah, like here is the thing, and I think right. Well, quite, but again, that comment being lies now or comments are lies now or lies in the future, right?
Yep.
So the fact that that's not enforced by the syntax of the builder makes it problematic, and the fact that it is so patterned means that we could trivially make an extra function on the builder, which is just export service request builder dot for root span only, for child span only, passing that one ID, and we could tidy it all up underneath it and it'd be good.
Okay, so we've only got, I think, one more test in here to go through.
Yeah.
So does that make sense that we are...
So let me read the assertions first because I'm a little bit... okay, so we're posting the child span only request. So basically this is, you got the child span before you got the root span, so you're waiting, right? Is what we're doing. So let's read the name. So root span in second request should send child span. So what you're saying is when the root span is then received, you send both of them.
Yes.
Right. That's what the name of the test should be. It's more. What we're actually saying is child span arrives after root span. Is that what we're saying? No, we're saying root span. So we're saying root span arrives after child span. Should send both after
single trace with two across two requests.
Yeah. Only sent upon
root span in seconds.
Root.
Should send both spans.
Yeah, exactly that. Should send both spans when root span arrives. Because otherwise you could think, is it going to? Because it's not going to. It's going to wait and batch them, right? That's the thing.
I think that the idea of the test was I wanted to make sure, and the test above says that we don't send the child span if it's only the child span.
Yeah, and this is the inverse, right?
And this is it's not the inverse. This is actually the next stage of that, to say, well, this one here, if I send a root span in, and that actually doesn't say root span on there, so that's probably I would still keep that test, but I should probably have another test which says with only a root span it just sends it.
Well, so my question is, if we go down to the test, are you actually asserting what you think you're asserting?
Okay.
I'm not sure you are. So we wait and we post the first thing, then we do the second thing, and we're now asserting that both have been sent. That is one category of test, but I think we're actually missing a test here, or we're missing an assertion between those two steps that nothing has happened.
But that's what this one's done.
It is, but it's not invoked twice. So that one could never do it if it tried. Maybe it's a secondary test once we want. And it,
look at the assertions. Read the assertions properly, though.
Right. Okay. Should not be empty. Should have single item. So you're testing that it gets batched.
Yes.
Right. But you're missing an important thing here. When it's sent is important. Not just the fact that it's batched. The fact that it's sent together, and I mean, I obviously can't imagine how it could be sent between line 95 and 97, but there's nothing there stopping it.
Yeah, but
like so for instance, this test would still pass. That test I could break it and make the test pass. I think. Right, I could break it. So if I I could send the first request, and I could send nothing on the second request, and that test would pass. Because you'd end up with, I mean, there'd have to be a bug and you'd have to send double data, but because there's two spans inside of it. I just think the fact...
I think I'm covered there.
You reckon?
Because the first one here, this one here, would fail if you send after the first request. This test would fail because that wouldn't be empty anymore.
I stand corrected. You're right. You're right. You're right.
Can you say it again? Because I like hearing that.
I got nothing. Plead the fifth.
So yeah, like I say, I think that's covered.
Yeah, there's too much going on in the setup again here, but there's no. I'm not going to flog a dead horse.
Cool. So, and then the final test.
Root span in second request for unrelated trace should send unrelated span.
Sorry, that is a problem on my part.
Ha! Okay, that makes more sense. Okay, so we have, and again, if we slim down those attributes because I don't care about them.
Yeah.
We give this builder a haircut. Right, so formatting is not your friend.
So let's just get service ID in there. Yes, I could just do a find and replace, but I'm not going to.
No, it's fine. I mean, the actual
attributes either.
Yeah, and in fact, the second pass of this is taking out all those three setup things that we don't care about and putting them in the constructor for X unit just so they're there.
Yeah.
Just get them out of the way.
Child span only request is, so what have we got? Root span in the second request
for unrelated trace. So is that meant to be different?
So that's just making a. So that one is parent span ID.
Yeah, then
that has not been sent.
Yeah, and then let's do the same. We elevate the other one, so we've got two obvious different spans.
Well, the other one doesn't have one.
Oh, it doesn't have one at all. Right. Okay. Of course, there's a lack of a parent
because it's
ID,
and this is the change because that's actually in the name of the extension method.
Yeah. Okay, and then we scroll down, and I guess I can imagine what the assertions are going to be like there. Again, I would probably give it a bit of breathing room between 131 and 132, just because you're cramming your assertions right up.
Also probably
do the same kind of setup-y stuff above, yeah.
Move that one to there.
Yeah, and in fact close the gap between the two calls completely. I would even fold that. I'd take 130 out because then you've got your kind of your AAA piece there, or your A space breathe space. That's
I've got my AAA space AA.
Yeah, again, it's like screaming. Okay, so no recorded requests.
I think if you Googled that, you'd probably find that there's a metal song with that as its only lyric.
Literally, there's a song by the band Strapping Young Lad called Ah. A. It's excellent. Exported data, so we're saying get the first request, and there should only be one because we're not sending that second spam because it's just another piece of data that's arrived and we're still waiting for its parent to turn up, right?
Yes. And that was
Perfect.
because we've sent a root span in, and I didn't want it to just assume and send everything in the buffer.
Yep, that makes sense.
Okay. So we've got some decent tests there. That's
Yeah. I think you've nailed the test cases completely. I think you flubbed the builder slightly,
yep.
but the intent of it is correct. And yeah, I think this is pretty good. I mean, the fact that I've managed to internalize this stuff in kind of an hour.
Yeah.
It's certified not hateful.
Exactly. I mean, I think there's a part of this that you and I kind of
we worked together enough that you knew you weren't going to disappoint me, right?
Yeah.
Live on stream.
You know, I did kind of know that this was pretty good because it's a lot of what we've done before. And I did spend a lot of time on it. I didn't just rush through and just write some tests. I spent time on this stuff.
I think the bit around the builder that is, and I think if I were to articulate it as a rule, right, and again, rules are for chumps and always have exceptions, so kill all rules. But my kind of rule of thumb with these kinds of builders is the amount of syntactic sugar and like programming language boilerplate should be less than the amount of crucial data that they reveal. Okay. And I think that's the bit that we're struggling with here is like there's a lot of chained method calls and func callbacks, all really to provide a string that is different in a couple of different cases, right? And actually, the vast majority of these test cases that we've looked at is there's either a function with a parent ID or a root ID, and nothing else about it we really care about whatsoever.
Yeah. And this is the thing. I was thinking about two different ways that I could do this. And for clarity's sake, and I didn't tell you this before, the builder was what I was hoping for help on. Because I'm happy with the tests. I'm happy with the structure of those. I'm happy that it's really testing a lot of things. One of the other cool things that I did with this, because I've actually implemented a Redis store for the tests, for the stuff. So you can actually change in the setup. You can actually just add a backend is Redis.
I do enjoy the wonderful irony there in that to run these tests locally on your machine, if you're not already using enough memory, you can also spin up a Redis instance to use some more memory out of process on your same machine.
And that's how I justify having more RAM. That's
no, but I appreciate the value because what you're proving there is that these tests can be run with an actual connected server, so you kind of go over the process boundary and you don't end up in some weird serialization place where you could go wrong. So it's
and one
valuable.
of the things that I'm hopefully doing is I'm going to create just smoke tests, some small smoky tests that I can do the Redis thing in memory on a server and only test the serialization stuff. Because this is the other thing that I know we saw this quite a lot with people over testing.
You just replicate the same functionality in every possible test and you just don't need it.
Yes, and it's like I'm testing that my application logic works when it got something from 5 different databases. Well, all you really need to know is, did my serialization from the database come back properly? So I'm going to be creating just a smoke test thing, and then in the build pipelines, I can run the in-memory stuff, which runs rapid, like these tests at the moment, and these are testing the whole of the application. This is not going to the controllers. It's doing serialization with protobuf, and that's 6 tests in 490 milliseconds. And I can tell you that about 350 milliseconds of that is
bootstrapping, right?
Up the hotel, the web factory stuff.
And that's fine. That's meant to that's allowed to take some time.
Exactly, because that's run once, and that's the other thing I did. Because these are all collection tests, I made it multi-tenant. And the reason I made it multi-tenant is because it makes it better for testing. Not because I'd envisage people running this in production as a multi-tenant thing. But if I make it multi-tenant first, every test is a tenant, which means you get inherent isolation within your tests that you're never going to get across trace ID between two different things. You're never going to get across data store between them. And that was a bit of a, oh, that's cool.
Yeah, it's cool. It's a nice side effect.
Yeah.
It's an unintentional benefit. We'll
exactly. So yeah, there's the builder stuff, which I wanted to do. The other thing, all of this is pretty simple. Like the code inside of it, all of that test, and this is another thing I wanted to try and get across to people, is if you look at the amount of test code to actual code that I've wrote to make that thing do that, it's probably about 5-1 right now, and it's going
100%.
to only increase.
100%.
Because, well, it takes the export request, bunches it up, and does some stuff. And obviously, I would say my test code is probably nicer than my application code.
Yeah, that's ugly.
Exactly. And that was actually hard to make work when I was doing the split of child ID and child span and root span. It was actually really hard to make all this work. And that's what I think that people forget. Is your test code is really nice, should be really nice.
Your test code is your interface into your own software.
Yep.
You're only ruining your front door if you have bad tests.
And that's all it does. It just adds stuff to an in-memory concurrent dictionary, and then gets them out and sends them.
You made link as a service.
Yes, basically. I mean, actually, I think the most amount of code is in the protobuf serializer, which does your favorite thing. It does tons of reflection, but it only does it once and then stores it. So
we're all good.
Cool. Right. So the builder. So before I open this builder, please don't judge me.
Is this? I apologize in advance.
So interestingly, the create valid export, which is the one right at the top, that first test, doesn't actually use the builder, and it probably could. So we'll ignore that one because that's.
So interestingly, so these are the types in the client library, right? These scope spans in I presume the OTel standard library or something like that.
Yeah, so it actually comes from, so it's all built from protobuf, and if you look in here, collector proto, that's all built from it. It's in here. So this is what I did is I submoduled the OTel protocol protobuf files into this, and then had my types generated automatically from that protobuf.
That's 50% like why do you hate yourself, but also cool.
So all of this comes from protobuf, and that defines all of these types and how they all build up.
Sure. Okay, cool.
So the builder, which has builders of builders.
Yeah, I'm curious. I'm curious.
So inside of an export request builder, I have a trace builder.
Yeah.
Inside of the trace builder, I have a span builder.
Okay, I see how you've done it.
Because trace is the top level concept, but it's not a thing you create.
So what, this is fine. It's one of the ways that you could make these build. Another way that you can do the same trick is you have all of your builders being inside the same class, but you implement multiple interfaces that expose different subsets of the methods on the class. So when you return it as whatever interface it is. So you only have one class that you're just calling between. I mean, it's fine, right? You can separate it between classes. It just means you pass less stuff around because you're in the scope of the same instance. So it's a little bit less head fuckery.
So I made this so that when we say with trace, so this method up here, Ignore the build one is a nightmare.
That's some gore.
That one is the oh dear.
Yeah.
There'd be dragons. So
Yeah.
one of the things I love about this is in VS Code, like we don't care about that.
Yeah, that nice. It's the definition of a hand wave is line 97 followed by line 135. Put it in a partial class. It's fine. It doesn't exist.
Yeah. So when
You didn't hear that from me.
So everybody who works at New Day, David said. Okay, so when we do with trace, there's a couple of different options, and this was me making it a little bit easier. You could say I want a static trace ID, and the reason why that's important.
You see, I think you're biting at this from the wrong angle.
Okay.
The first thing I would do is I'd go back to the tests and realize that every single use case is exactly the same. Like, so if you go into you could literally build an additional helper function in this exact class that just picks up the one use case you have in all of your tests. And all of a sudden, you're instantly in a better place.
And that was one of the things I was looking at doing was, do I build a with child span that takes a parent ID?
Yeah. And I think that's what I would, because that is, I suppose, what I perceive to be. So what you have here, it's interesting. There's probably a subtle semantic difference. You have a builder class, but you haven't implemented the test data builder pattern, which is very specifically, I mean, I say as specifically as a pattern that simple can be, is there's a single method that returns known shapes of data, sometimes with a couple of different options on it. So you built a builder that makes construction of the objects easier, but you've not actually captured the shapes of data at all. And that's still kind of in the test, despite the fact that we've all the way through this. I don't actually know what I'm looking at here because all I saw was I think the sharing would not let me see the square that you were pointing at. Yeah, all what we really have here is we have a child span, a parent span, and that's all we have. Those are two things. There's two functions, and we can say a child span with this ID, or with just a child span, you don't provide the ID or generate ID. Who cares? What I would potentially do is maybe, I don't know, maybe return something from the data builder, like the ID of the span created or something, so you could assert on it. There's possibly some other bits, but thinking on my feet.
Yeah, I mean.
But I would start off just by literally copying line 112 to 119, making a function called child span only, which is just a static on the export service request builder type.
Okay, so a couple of things to note here. The with span, the with service thing, has an extension method.
Yeah.
Because services can have attributes that exist only for the service and not for each individual span.
Which is really cool, but you've not used them.
I haven't used them in here, no.
Yeah.
So we could remove that. And if I was to say that this looked something like... Because this is one of the other ways that I looked at building these up. Was if I was to make that
much better,
look like that,
much better.
The reason I don't like that is because it's not obvious what that does.
But you only have to click once to find out. Because I could argue that you're right, it's not obvious what that does, but it's equally as unobvious that we're creating a protocol buffer message, but it's not important.
So
you can find out.
That was one of the other ways that I was looking at doing this. And
I would literally just say trace.for parent child.
So go on, dictate that out.
I'd probably have like a trace.for, and that takes two parameters, the parent and the child
like
ID.
So do trace dot.
Yeah. Just two things, yeah, parent and child ID. Parent ID, child ID. And I think that captures exactly the sentiment that we're talking about, right? And I would potentially, even in the tests, use that same trace.for, and I might pass a null and a child ID to represent.
So it's not trace.for though. So here's in.
Well, imagining it in
span.for.
Sure.
And it would actually be span dot with parent ID like that, because it's not trace. Trace isn't a thing that we've created.
Sure. Sure.
So
I was just looking at the word trace in on 116.
yeah, and
Yeah.
this is part of the hard part of this, is modeling trace and span in the right way. Is proven to be quite hard from a model
span. Yeah.
perspective.
I mean, a span with parent ID. I like that. I think that's really simple. I think it's obvious. So, and again, when you talk about the model, yeah, that I was going to say a span, right? The word trace there is just an artifact of where we copied it from.
Yeah.
Yeah, I think that is really simple.
And then
none of the rest of it is really it's all syntactic noise, right? It doesn't matter that.
So something's got to create. I mean, for this particular one, no. But when we get to these other ones,
So okay, so the
there's
other one
two
here.
different traces happening, and I need the trace ID in order to do some things. This, I could do. I think we've actually got this.
I was going to say, does the span, does the object have the ID on it? You just read it out of it.
So on a span builder like that, yes, I could override that one and have.
No, but even when we actually have the span type, is the ID readable from it?
So from something that like the span builder like that, yes.
But not once you build it.
Not once you've built it, because you've then built something called a scope span instead, and would have to delve into a scope span to.
That's the. Did you just tell me to go fuck myself? And like, cool. No, you think you got a span, but you think you got a trace, but actually it's a scope span. So no.
Yes, it's like you don't have a trace. What you have is a series of scoped spans, and those scope spans might have one or more trace IDs. So you might have a trace, you might have lots of traces.
Okay, so an alternative approach that I would use in that case is I would make my own POCO, just a type, which contained the few small pieces of test data. Right, so parent ID, child ID, and that's all we're using in this thing. I'd then build an extension method at the end, which would be like to export service request.
So I do have convert to span, which takes a span and converts it to a span. Which I was particularly proud of that particular
in case you're not spanny enough.
Yes, it takes a span builder and converts it into a span. It doesn't build it, because building it wouldn't be the thing that it's doing. It's actually,
Because I feel like all of this backflipping around this kind of fluent interface is all really, we're just collecting 2 or 3 pieces of data, right? It's just what's the ID of the thing, what's its root ID. You could just make a tiny, like a record type that represents that thing to capture your test data in, and an extension method that then uses that as a bag of data and constructs your ugly object, because it's only going to happen in one place.
Yeah, and I suppose I was leaning on the with and for.
Yeah, I like what you've been going at here, but I think you could have the with and for even on that and that is a more literal interpretation of the test data builder pattern, in that type that you've created is a representation of the test data, not the internal representation of the data types that are required to be serialized to flow over the API. It's a data catalog, albeit of one kind of data, which is spans.
Yeah.
And I think the amount of code that it will require to do that is so much less than the code you've had to do to build this DSL. And it's one of those, like, it's a little bit disheartening, because I know how long it takes to do the fuckery to make fluent interfaces.
Oh yeah, I mean this, and this is the thing. The same with the tests. This is something, and we've only got 5 tests there.
Yeah.
There's going to be hundreds.
Yeah, but are the dimensions going to be much more different than what's the parent, what's the child, what's the attributes?
There's going to be lots of different
kinds of attributes.
Yes, there's going to be lots of spans in a particular request.
That's fine.
Because some of the things that we need to do, if you go think back to what we were talking about with how do I know that one trace is similar to a different trace?
Yeah.
There's going to be some of these tests which create a trace with 5 spans.
Yeah, imagine how long how much builder code it would take to do that.
Yep. And this is what I've been trying to do
Yeah.
as I hit that and go, oh, this is quite hard.
It's a bit too big, yeah. I honestly, I think Poco for the test data with an extension method or a static, I mean, same thing, like static function extension method, that then picks up that thing and goes, okay, make me like the ugly bit is just one function of the ugly bit that iterates through the test data, and really you're just gluing 2 or 3 strings and then optionally a dictionary of data, which is a single loop or a link statement.
Yeah, I mean, there's like I say, there's quite a bit of nuance in that trace ID, span ID, and parent span ID all need to be stitched together.
Yeah, you need to make sure the relationships between those are correctly right.
Yeah. And that was one of the reasons why.
Correct.
That's one of the reasons why with span exists. So if you did with root span there, and then did span dot that, then you could do dot with span with child span there.
Or
which
okay, so
goes
but
into that,
interestingly, you could
span.
model that. You could model that even more trivially with the data by just having a parent attribute that you can just set the reference to. You just say, for parent, and you point at another instance of the Poco.
Yeah.
And then you just follow that. Like, I think it actually, ironically, the code required to generate the real data would be less.
Yeah.
When you liberate yourself from trying to satisfy the contract and I think that was the do you like pain when you generated types from protobuf, because basically you're fighting that pain of having to satisfy the type definition and structure of the actual protobuf wire format in your tests, and you just put a thing in the middle.
Well, I haven't though, and that's the thing. I really simplified it.
Yeah, no, I mean,
and create some new concepts, because what I tried to do with the tests,
I see that, yeah,
was build the mental model that people have, not the protobuf model. Because I could build the protobuf model, and we've seen the protobuf model, which is
and suffer to everybody. Yeah,
like nobody wants to do. Where is it? My that build method there. Nobody wants to do that ever. Like that is a nightmare of code to try and understand where scope spans are, what scopes, and that's actually changed, by the way. It's now instrumentation scope,
of course,
because that's in the new 1.0 spec. And this will either have to do both of them or none of them. And that was one of the other things. It was, I might need to in here do a build v1 versus build pre v1. So
I guess the way I would walk us towards this, if we go back into our test, I would first literally make that. I would take the exact invocation pattern we have with each of these, and I would make a new function in your builder that's static, that's just exactly that block of code. Right, that's the first step of the movement. Because then it localizes where you rework the builder code.
So
you basically got a function. You require a function that takes in service name. That's it.
Okay. So
that literally just takes in service name.
So what are we calling it with root?
You just export service request builder dot build root span, just for the sake of argument for the term.
Build with root span.
Well, that's just a root span, right? You're not even building with a root span. You're just building a root span.
Well, if we're doing it on this export service request builder, it would be building a full request that has.
Oh, okay. Yeah. And then I just copy paste the lines underneath it into that, and then I go and that'd be my first pass kind of slimming of the tests.
Yeah. So you'd end up with that. And then on this one, you'd have build with child span only. And then we'd have
parent ID. Yeah. And then I'd rip that and put it underneath it. And then we can delete those sketchy lines above. Yeah. And instantly, I can see what we're doing here because we've taken away the noise.
Yeah. And this is it's the balance at this stage of the flexibility that I know I'm going to need. And this is, I think, one of the biggest problems in development is building for things you don't have yet. And one of the reasons why I love this way of testing is that you don't build things you don't need yet. Because if the test works, then...
And it's bitter, isn't it? It's like, no, don't need it. Like, and the thing is, when I see that, what I would probably end up doing now, like, if I was looking into the future, I think I would build, I would pass in an action, an optional action to those two functions that let you modify, that provide you the builder, that let you bit twiddle, right? Yeah. And then for most cases where it's only a single bit you're twiddling, that would be totally sufficient. And in some cases, you would find, oh, actually, I need to mutate, like I'm doing all these, like I'm setting all these attributes or whatever. And then the attributes you're setting would be extracted into a different data builder that captures this set of attributes is like for a very, very wide span request.
Oh, yeah.
Or a very, very narrow, like you capture that dimension separately.
And one of the things I was looking at was the common scenario that you get when you start building distributed systems is one service calls another service. You've got a HTTP inbound request, which will have a user agent on it. It'll have the root, the URL. It'll have some common attributes, and OTel gives us all these what they call semantic conventions, which will explain some of those things.
Yeah.
So what I was going to do was say when we do with span, there would be like with HTTP inbound span, which would set some of these URLs randomly and all of that kind of stuff, and then that would have a descendant thing that says with HTTP inbound outbound span, etc. So I could start to model what something would look like.
Yeah, generally the other place that I would consider changing in these tests is, again, I think there's like a two-step operation here, because there is an invisible thing, which is the protobuf magic, right, which has been tidied up into this like export request thing on top of it. And there's a chance that I quite like extension methods when I'm doing format conversion. Yep. So I would possibly take that like protobuf ugly bit, and I would generate my model. I know that the point that I'm sending it, I'd add an extension method call, which is like, to protobuf request or something, which just captures that, because then it's kind of visible in the test that this is protobuf and it's something you should be caring about. But it doesn't really change the flow of interactions that you have in the system at all, particularly.
Yeah. Cool. Well, that's given me a few more bits to go on. And yeah,
that's fun, man.
Yeah.
It looks good. I think you've done a really good job here. Like, it's a cool, they're really nice tests.
Yeah, I spent way more time on tests than I have done on any of the application code. And this, like I say,
so application doesn't work. However,
well, no, it does, because the tests tell me it works.
There we go.
And one of the, we know that the power of these kind of things is I can change the entire implementation of this stuff really easily, and I've done that so many times and had that confidence, but I've spent so much time on it. And I think one of the big problems as developers that we get is we want to write the application code because that's interesting. Writing that application code is really interesting in that, how does this algorithm work? And, when I look at the sampling stuff and I talk about the trace processor, we've got like 7 or 8 different algorithms in Honeycomb about how we do different things with moving averages and exponential averages, and these are all really interesting algorithms to write. And I want to write them, but I can't write them until I've got an application that they live in, and I don't want to write an application that they live in if I don't have confidence that
if you can't prove that you've got the application right. Like, at all.
And I want to be able to just go, yes, this thing works, and now I'll add a load of algorithms and make sure it still works.
I think it's very easy to get code blindness as well to stuff like this, where you get so into the domain, and the terms make sense to you because of course they make sense to you. And like it's interesting watching you highlight oh yeah, well, we've got traces but also spans, and some spans are parents and some are childless. It's like, oh, okay, so actually this thing that sounds simple, which the one liner, oh, OpenTelemetry is just sending spans, but is it?
Yeah, yeah,
And I think that the devil is always in the detail of those kinds of implementations, but yeah, it's cute. I like it.
yeah. So,
Awesome.
but yeah, thank you so much for coming on.
My pleasure.
And I hope that other people have got where my mindset comes from when I start doing these talks. And come see my talk, which is all about using this kind of approach to build more operable software. Go see David's talks. They're all on YouTube as well. Both of our talks are on YouTube.
Yep.
About tests that don't suck, which is all about writing these kind of intentional tests that do all this stuff. And then obviously your intentional code talks, which are pretty cool as well. I should probably go and see one of those. But yeah, so thank you so much for coming on.
Good
We will be
pleasure.
back probably a week on Thursday, seeing as I am in Berlin for We Are Developers next week. So hopefully we'll be back a week on Thursday. Maybe Jess will do her own stream. I don't know. But other than that, thank you very much for listening, and we'll see you all soon.